LINQ Chunk versus MoreLINQ Batch. You all asked for it, and I'm here to show you the comparisons. Hi, my name's Nick Cosentino, and I'm a Principal Software Engineering Manager at Microsoft. I started creating a video series demonstrating features from MoreLINQ, and I will continue to add to it, but one of the first responses that I received was when we started looking at MoreLINQ Batch. Folks were asking, hey look, MoreLINQ Batch, well what about LINQ's chunk method? Can we start to look at some of the performance differences between these two things? And I figured this would be a great video to demonstrate the behavior, and then we can look at the benchmarks. So if that sounds interesting, remember to subscribe to the channel and check out that pinned comment for my courses on Dome Train. With that said, let's jump over to Visual Studio and compare both of these LINQ methods. Okay, on my screen right now, I do have the MoreLINQ batch method. I'm just going to go put this back into debug, and I'm going to go run this, and we'll see what batching looks like. Now, this was covered in a previous video, but what batching will do for us, if we zoom in on here, is when we have a batch of 3 across this set of numbers 1 to 10, it will break it up into multiple batches. I was going to say 3 batches, but it's 4 batches, each of a size of 3. And of course, this final batch is just 1 element because there's only 10 items. Chunking works the exact same, so we don't need MoreLINQ for it. You can see Visual Studio has made it grayed out. I can even delete it. This is built in to LINQ now, and I'm going to go ahead and run this, and we should see that when we chunk, we get the same type of output, right? So 1, 2, 3, so chunks of size 3, and there's 4 of them, with the last one being a different size. This is valuable for us to be able to split up collection sizes, but now at this point, we have 2 different ways that we can do it. And in the original benchmarks that I showed manual ways of going to do this, but it's really better that we saw to be able to use built-in things or things like MoreLINQ to do this for us. What's going to be the difference between MoreLINQ's batch and the built-in chunk from LINQ? Now, I should call out that MoreLINQ, as it's been developed over many years, it has had methods that were added in, so a lot of these extension methods that over time we have seen variations of these added into LINQ itself. Chunking very much looks like batching, right? We just saw it's the exact same behavior, so this seems to be one of the extension methods that was probably in MoreLINQ, and over time we had chunk added in to be available to us without any NuGet packages. But now that we have people that are using MoreLINQ, and you're getting these things built into C# for us to be able to use, which one should you be using? So let's go look at the benchmark setup, and then we'll look at the benchmark results. So I did mention in a previous video that I had benchmarks on this. If you have not seen that yet, I'll link it right up top and you can go check that out. But what we're going to be doing is basically not looking at the manual chunking approaches that I wrote, so these are all commented out, and instead we're going to compare MoreLINQ's matching to LINQ's chunk method. And if you notice, these two benchmarks look very much the same in terms of how they're set up, except one is going to use chunk, this is from LINQ, and the other one here uses batch, and this is from MoreLINQ, so that NuGet package that we're talking about. Otherwise, all that I'm doing is forcing enumeration across everything, just to keep these the same, right? When we deal with LINQ, so you can see the return type is an IEnumerable. This means that it will be lazy, right? Doing something like batch or using chunk, which also returns an IEnumerable, when these are implemented as iterators that yield back data, the sort of call to batch or the call to chunk is almost instant. You're not doing any work until you evaluate. So just to make sure everything was consistent, I am going to essentially enumerate over every element just to keep it the same. If we go up a little bit higher, we can see that the parameters that I'm going to be using are collection size. I just wanted to make sure that we could go across a spectrum of very small collections up to very large ones. And then I am going to be batching. The first sort of size of 1 means that we're not really batching. It's just going to be iterating over everything individually. But given that we have these 2 different APIs that we can use, we'll be able to see how they treat that when you basically have a very, very small batch size versus up to something that's quite large. Before we continue on, this is just a word from this video's sponsor, which is Pact Publishing. Pact has sent me yet another amazing book by Mark Price, and if you don't know who Mark is, he's created many .NET books. They're available on Amazon, and they're all taking over the Amazon bestseller section for .NET topics. This book is called Tools and Skills for .NET 8, and it's available on Amazon, like I mentioned. It's filled with tons of information, including things like AI prompting, LLMs, and different things like Copilot that you can use in your development. And it focuses on all of the tools and supporting things and not just language features, like a lot of other resources that are available. So I do highly recommend this book from Mark Price. Just like all of his other books, it's filled with tons of examples, and it's sure to help guide you in working with C# and .NET. Thanks, and back to the video. That's going to be the setup. Just a quick reminder that when you go to do this kind of stuff, you do want to make sure that you are set up in release mode. This is using benchmark.net, which hopefully many people are familiar with. If you're not, you can check out my channel for other videos on getting started with benchmark.net. Not going to go into the details in this one, but with that said, let's go check out some results. All right, my screen is filled with numbers here, and we are going to be looking at basically MoreLINQ matching compared to LINQ Chunk. Just a reminder that the first line in each little grouping here is going to be MoreLINQ's matching. So between each pair, MoreLINQ is on the top. Standard LINQ with chunking is on the bottom. There are a couple of columns that I want to call out. So obviously these columns here, I'm just going to circle them in red with a terrible mouse outline here, but these are going to be the parameters that we're using. This column with the ratio, I think, is going to be extremely interesting because this is going to be where we're comparing performance relatively, and same with the allocation ratio on the far right-hand side. The other interesting columns are this allocated one. This is going to tell us the overall allocated memory that's being used. And then, of course, the mean column is this performance column that we're interested in. What's very helpful, like I said, is looking at the ratio column to be able to immediately tell us if there's strong differences between the two. If the numbers are very close to both to 1, then they're going to be very similar. I did make LINQ's chunking method be the baseline, so LINQ's chunk will always be 1, and that will mean that MoreLINQ batching, having a smaller number in the ratio, it will mean that it's faster, and over here in the allocated column, if the top number is smaller, it will mean that there's fewer allocations. Conversely, if the number is greater, it will mean that it's either slower or having more allocations than standard LINQ's chunk. So with that said, let's start diving into it. In the first case, where we have only a very small set of 10 elements and we have a batch size of 1, this is kind of a crappy situation to be in when you're batching with 1, right? And this is going to be a similar pattern we'll see throughout all of this. But when we batch by 1, we're effectively not using batching for a very good reason, but I wanted to demonstrate what it looks like still. You can see that MoreLINQ is going to be significantly slower, like 40% almost. When we have that, allocations are almost the same, so not a huge difference here in terms of allocations, but the performance is worse compared to standard LINQ's chunk. If we start to go down a little bit lower, and I can do these in a bit of a grouping here, right? If I highlight this ratio section, what you'll notice is that MoreLINQ's batching is from about 75% of the time to down to half the time in terms of performance when we're dealing with a collection size of 10 and a greater batch size. So that's quite interesting because it is a small collection size still, but effectively it looks like there's probably some optimization that when the batch size is greater than the collection size, that MoreLINQ batch is doing something to kind of short circuit that functionality. I haven't checked out the code, but that would be my expectation when I see performance characteristics like this. And interestingly, if we look at the allocated column, we do have significantly less memory allocated. I mean, we're only talking about not many bytes, but less than half the number of bytes allocated for MoreLINQ's batching, which is better. So that's quite interesting. Next grouping is going to be the 1000 element grouping. And if we start to check out the ratio column, so I'm going to highlight this part right here. Kind of interesting in the beginning when we're doing a batch size of 1. Both of these have very similar performance characteristics, and the allocated part is the same. So when you start to do just a size of 1 for batching around 1000 elements, not really any different. But we do start to see some very interesting behavior when the batch size is the same or greater than the collection size. So these parts down here, right, you'll notice that MoreLINQ's batching is doing significantly better. And this is sort of illustrated here in the allocated column as well. I think that what's happening is, like I said, there's some short circuit logic that says, hey, look, the batching that we're doing, it's the same size of the collection. Let's just kind of jump out of here pretty quick, but kind of interesting. I think it's worth calling out. Next section, this is going to be, what is that? That's 1 million records. So I'm going to highlight this group here as well. This is where we're going to start to see that the tables turn a little bit. So when we are getting into actual batching, right? This is actual batching happening here. For the most part, there is still an outlier. When we are getting into splitting up the collection into chunks or batches, it does look like the standard LINQ chunk is going to do a better job in terms of performance. So this one where we're splitting things up into the single element chunks. In this case, once we start getting up to 1 million elements, we can see that MoreLINQ is going to be underperforming by about 20%. When we start to do the chunking, so right here, so this is where we're going to have chunk sizes or batch sizes of 1,000. It's about 25% slower with MoreLINQ. And then it's a little bit slower, not by a whole lot, but when we have 10 batches or 10 chunks of size 100,000, they're very comparable, but it's a little bit slower for MoreLINQ. And then finally, when the batch size is the same, we always seem to be seeing MoreLINQ really shine through. So I just wanted to call that out. Sort of the pattern and one of the takeaways from this video was that when your batch size is the same, MoreLINQ seems to do better. So I am curious if there's a really good optimization opportunity in chunk in the standard library that we could have this optimized for us. It's probably not a super common thing. Like, why would you be chunking things and having them the same size? But I mean, if you were writing code like that, it would be nice if it was optimized so you don't have to worry about it. If we jump over to the allocation column, again, we do see that the first two at least are very comparable. Let me highlight all 4 of them though for us. First 2 are basically spot on in terms of allocations. We do see that MoreLINQ, even though it was slower by a little bit, right? It did have fewer allocations, so that's interesting. Maybe that's one of the considerations that if you were looking for a little bit fewer allocations and the performance is on par, you might want to consider MoreLINQ batching for that. But again, this short circuit logic, or I'm assuming short circuit logic is allocating fewer bytes, which is pretty cool. And finally, we're going to jump over to the last section, which is going to be the 10 million collection size. Let's go highlight down here all of the ratios that we have. Single elements, again, slower with MoreLINQ batching. And then the other 2 where we have a batch or chunk size of 1,000 or 100,000, a little bit slower with MoreLINQ as well. So roughly 4% or 9% slower in these cases. And that's kind of what we started to see happening in the previous set. And then as well, when we, because this final one is not going to be the full batch size that equals the collection, right? If we have a quick look, I know these numbers are kind of hard to see written out here, but the collection size in this last grouping is 10 million, and this batch size or chunk size is only 1 million. So this is why you're not seeing MoreLINQ's batch pull ahead again here. And that's because the collection size and the chunk size are not the same still. So it does seem to be that when we are breaking things up into chunks using LINQ Chunk, we do get better performance characteristics, especially with larger collection sizes. If we jump over to the memory allocated in the far right column for this example, it's either on par or a little bit better, right? Like this is, I would call this one basically on par. It's 99% of it. This one's 91%, so you can see that it is starting to drop a little bit in terms of allocations relative to LINQ's chunk method, but it does seem like they are relatively comparable with allocations. Across the board, MoreLINQ seemingly allocating a little bit less than LINQ's chunk method, but as we saw, short-circuiting logic seems to exist in MoreLINQ's batch, and the LINQ chunk method that's built in for us seems to do better for us in terms of performance when we have larger collection sizes with batch or chunk sizes that do not equal the entire collection size. Hopefully you found that interesting. I'm not here to suggest that you must use one or the other. I'm just trying to, number one, present some data to you to think about. Number two, show you that you do have some options. And number three, remind you that you do have tools like benchmarking to be able to try these things out. So in this case, because these APIs are identical, you could try it out in your real code, right? You could go benchmark your real code and swap these implementations out and see which one overall will perform better in your situation. Thanks so much for watching. When the next video is available for more LINQ examples, you can check it out here. Thanks, and I'll see you next time.